So we're going to start with our review questions for today. So question 1 is asking us to take the point P, which lies on a function. This function has been translated 4 units vertically up, and then it's been reflected in the y-axis. So that means that our x values are changing. So I need f of minus x. So the negative is going to go in front of the values that are changing. So here I have my point 4 of minus 3. Now here between the two, I'm going to do my horizontal dilation first because that's my order of transformations. So that means I have to multiply my x value by minus 1. So here that will become minus 4, minus 3. My next one is going to be a vertical translation in that the y value is moving up by 4. So minus 3 plus 4 will be 1. So my final answer will be A. Moving to question 2, we have the graph of this function of 3x to the power of 5 over 2. It's reflected in the x-axis. So here that means it is basically being flipped over the x-axis, so my y values are changing. So therefore, I have minus f of x. It's then translated 3 units to the right, so that's a horizontal translation. And then I'm going to leave that there for now because recall later that even though it's to the right, I'm actually having a notation that's the opposite. Then here it's 4 units down, which is a vertical translation, so it'll be a minus 4. So I'm going to start by capturing all of this in function notation. So here I'll have minus f. Now instead of x, it's been translated 3 units to the right, so it'll be x minus 3. And then 4 units down. So now I'm going to replace this x part here in my function with x minus 3. So I will get minus 3 of x minus 3 to the power of 5 over 2 minus 4. And you can see already with the multiple choice, the minus 4 is only captured in this answer here with B. So therefore our answer is going to be B. To question 3, it says list the set of transformations that when applied in order, transform our parabola into, so our parabola y equals x squared into this one over here. So when I'm thinking about describing transformations, I like to describe them when they're in turning point form because it's easier to see. So to take anything into turning point form, I need to think about completing the square. So here I'm going to start because to complete the squared, I need a positive monic coefficient. So I'm going to take the negative out. I'm then going to look at, I've got x squared plus 6x. Now half of 6 is 3 and I have to square that to complete the square. I then have minus 1 and because I've introduced a plus 3 squared, I have to balance that with a minus 3 squared. I'm now going to factorize. Then I have minus 1, and then I have minus 9. So I end up with minus 10. Oh, sorry, I need a squared here. My last step is I'm going to put through the negative. So now I can see there are 3 types of transformations occurring. So the first thing I look at is, well, my order is HD, horizontal translations, vertical dilations, and then I'm looking at vertical translations. So here I look, there are no horizontal dilations, but there is a horizontal translation, which is going to be this here. So 3 units to the left. So shifts 3 units to the left. The next one I have is a vertical dilation, which is this one here. It's on the outside. So that means it's my y values are changing. So it's reflected across the x-axis. And lastly, I have my vertical translation, so I'm shifting the graph up by 10. So that's my answer to question 3. So we'll now look at example 12 from our previous lesson. So we're going to be looking at this parabola here, and we're going to be transforming it for part I and double I. So starting with I, the first thing I'm going to do is I'm going to choose these 3 coordinates to start my transformations with. So what I'm going to do is I'm going to do sort of like a table where I'm going to start by writing each coordinate. And then on the left-hand side here, I'm going to write the order of my transformation. So horizontal dilation, horizontal translation, vertical dilation, vertical translation. And we're going to tick off what I see. So this horizontal dilation, I don't have anything here, so there's nothing I need to calculate there. Then looking at my horizontal translation, I notice that I do have that, and it is a shift to the left. So I'm basically taking off 3 off my x value. So my x value is heading further into the negative direction. So here I'm going to take -2 and take away another 3. And my y value remains the same because horizontal only impacts the x values. My 0 becomes -3. My 2 becomes -1. Then I'm looking at my vertical dilation, and I do have one here. The scale factor is 3, so I multiply the y values by 3. So 1 will become 3. -1 becomes -3. And 1 becomes 3. Lastly, I do have a vertical translation. It is being shifted down by 2. So I take away 2 from the y coordinate. So here 3 take away 2. -3 take away another 2. And 3 take away 2. So here what I'm looking at now is when I go to sketch this, I'm going to label. So here I have all the way, I have -1, 2, 3, 4. Let's extend this out a bit more, and 5. And then I'll have 1, 2, 3. I'll extend this a bit more to 5. So here, my first coordinate is -5, -1, so around here. -3, -5, so around here. And -1 and 1, which will be around here. Oh, sorry, this -5. Sorry, I put that with -1. It should be with +1. Then what I'm going to do is I'm going to connect all this up here and draw my parabola. I'm also going to label my transformed functions, so my transformed coordinates. To show the marker, I know exactly how I've transformed and plotted these points here. Next, what I'm going to look at is I'm going to do the same thing but with double I. So I'm going to pop up another table. And write my translations here on the side. Or transformation, sorry. Now here I do have a horizontal dilation, which is here. Now with the horizontal dilation, remember that this here is our A value, which is 1/4. A horizontal dilation, I need the scale factor, which is the reciprocal, which becomes 4. So I'm stretching it across the x-axis. So now my horizontal dilation, my x values will be multiplied by 4. So -2 becomes -8. My y value stays the same. This is only horizontal. 0 times 4 is 0, and 8, 1. Next thing I'm going to look, do I have any horizontal translations? I don't. so I don't have to worry about that. My vertical dilation I do have, it is a scale factor of -2. So I'm multiplying all my y values by -2. So here I have -8 and 1 becomes -2. -1 becomes 2. 1 becomes -2. Finally, I'm looking at my vertical translation. I'm shifting the coordinates up by 3. So I'm adding 3 to the y values. So -2 plus 3 brings me to 1. 2 plus 3 will bring me to 5. And then here, -2 and 3 will bring me to 1. So here, I'm going to draw up my Cartesian plane. Now here, I have -8 and 1. I have 0 and 5, so I know 0, 5 is probably around here. Notice that this is, then I have here, oh sorry, I don't know why that changed to a 2. That needs to be an 8. So here I then have 8 and 1. Now the thing to be wary of here is that notice that 8, 1 is here, -8, 1 and 8, 1. Now notice here, that makes sense because notice that this graph has a reflection. So here it's going to be concave down. I'll just make sure to match that up a little bit better. So here I have -8 and 1, 0, 5, and then I have 8 and 1, and that becomes my transformed function. Moving to part B. So here, a little bit different, I have another polynomial, and this time I think I'm going to use all 4 points because I think they'll be very helpful to help me understand the trajectory of the graph. So here I'm going to look at I, and I'm going to do the same process again. So here I'm going to have -2 and 2, and I'm just going to list out the coordinates that I see. So that's going to be, and I'll just bring out our highlighter here, these 4 points. List out the order of my transformations. Firstly, do I have a horizontal dilation? I do. So I have a scale factor of -1. So I multiply the the x values by -1. So I do get 2 and 2. So I'm changing all my x values because I'm multiplying them by -1. Next, I look, do I have a horizontal translation? I don't, so I'm just going to leave that part or that row. I'm looking for a vertical dilation. I do. It's with a scale factor of 2, so I'm multiplying all of my y values by 2. So I get 4, 0 times 2 is 0. My 1 becomes a 2. And my -1 becomes a -2. Lastly, I look at my vertical translation. I have it shift down by 1. So I'm reducing the y value by 1. So I end up with these coordinates in my final row here. So now all I have to do is plot my points and then connect it all together. So that way I can have my transformed function. So here I'm just going to mark out just approximately. So here I have the coordinate 2, 3. So maybe somewhere up here, 1 and -1, 0 and 1, -2, -3. Now, I'm just recalling here that, see, this -1 and 0 is a turning point, as is 0 and 1 here. So what's happening is, notice that I'm having a reflection as well. Notice that my x values are changing. So I'm actually reflecting across the x-axis here. So when I go to connect up my points, what I'm looking at is I'm going to have turning points here and here. And then finally, what I'm going to do is just label those coordinates on the graph. Sorry, I don't know why I put those there. Should be just 2 and 3. So I end up with this here. Now I'm going to do the same thing here for double I. So again, draw out our table with our coordinates. And listing our transformations here on the side. Now remember here that when I have a coefficient of x as well as a horizontal transformation, rewrite the equation in factored form. The reason we want it in factored form is that allows us to express it in turning point form, which allows us to more easily identify our transformations. So first thing here, I'm going to look at a horizontal dilation, and that's going to be 2. So that means that my A value is 2, but my scale factor is 1 over 2. So I need to multiply the x values by a half. So here, I end up with -1, minus a half. 0, anything times 0 will be 0, and 1 and -1. My horizontal translation, I look into factored form. It is a shift of 2 units to the left. So here I'm going to minus 2 from all my x values. Next, my vertical dilation is going to be -3. That is the scale factor. So I need to multiply all my y values by -3. So this 2 will become -6. This 1 will become -3. And this -1 will actually become +3. Finally, my vertical transformation is a shift up by 2. So I'm going to be increasing my y values by 2. So now I'm going to start to sketch my Cartesian plane. I'm just going to plot a couple of points or just kind of do a quick indication. Just to kind of help me guide my sketching because I don't have any grid paper here. So here, my first point, I've got -3 and -4. So -3, -4 will roughly be there. -2.5 and 2. So -2.5 and 2. So that will roughly be here. Then I have -2 and 1. So -2 and 1. And then I'm going to have -1 and 5. So that's going to be all the way up here. So now what I need to be, +2. So this one here, -2.5 and +2. So it should actually be here, sorry. Now what you can see is that these coordinates are very close together. And that makes sense because what's happening is I have a horizontal dilation that is in which the graph is being compressed. And then I also have a vertical dilation in which the graph is being stretched. So here, when I connect those dots together, I get something like so. And now what I'm going to do is I'm going to label those coordinates. To finalize the sketch there.